Chapter 8, Practice for the Test. As you go through this practice test question packet, you need to ask yourself, what concept am I going to use to solve a problem? So when we're solving right triangles, to find a side, first case is you have or you know two sides. Then you're going to use the Pythagorean theorem, which is the a squared plus b squared equals c squared. The other case is you know one side and one angle. In that case, you're going to use trigonometry. And you'll need to determine which you're going to use, sine, cosine, or tangent, depending on whether you have the opposite, the hypotenuse, or the adjacent. To find an angle, you'll have two sides and you would use the inverse trig function. Again, as I've said, you can definitely memorize SOHCAHTOA. Even if you memorize it that way, I would always recommend that you write at the top of your test or the top of the homework that you're doing, just translate this into a list where you have cosine and you're going to have some angle. Excuse me. Let's start with sine. Sine and some angle, cosine and an angle, and tangent and an angle. And it'll be opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And looking at a triangle itself, it'll probably help you in the beginning. Let's say that you want to find angle A here. Label right away the hypotenuse, which I had H over there. Then determine the opposite side, and that's the side that's opposite the angle that you're looking at. And I had that as O over there. Then the remaining side is the adjacent side. So if you do have difficulties determining which one's the opposite and which is an adjacent, I would recommend marking them down first. So let's look at the problems. So problem number 1 here, we want to find x in triangle PQR. It is a right triangle. We have two sides. So we're going to use the Pythagorean theorem. This is the hypotenuse. So it'd be 5 squared plus 12 squared equals x squared. So x squared would equal 5 squared plus 12 squared, which is 169. Then you would take the square root of both sides, and the answer is 13. And yes, it is one of the Pythagorean triples, so if you remember 5, 12, 13, you can use that way also. And problem number 2. Again, we have two sides. We have 15 and 17. 17 is the hypotenuse. So it would be x squared plus 15 squared equals 17 squared. Because this is the hypotenuse here, I would subtract 15 squared from both sides. And I would have x squared equals 64. Take the square root of both sides, and I would have x equals 8. The next one is, which set of measures could represent the lengths of the sides of a right triangle? First thing that you do have to remember is that the smaller two have to add up to be greater than the third one, which is the longest side. If it doesn't do that, it can't be a triangle. A, B, C, and D all work that way. To test it, you're going to use the test is 2 squared plus 3 squared. Does that equal 4 squared? So 4 plus 9, does that equal 16? And the answer is no, so we know that A doesn't work. Another thing you can do is to look to see if there is any triples. For me, I see that this one is a 3, 4, 5 triple because it's 3 times 3, 4 times 3, and 5 times 3. So I'll test that one next instead of testing all of them. 9 squared plus 12 squared equals 15 squared. And I know what you're saying. Yes, I know it works, but I need to show it. On a test, I will allow you to write that it is a triple. So 9 squared plus 12 squared does equal 225, as does 15 squared, so that one is the one that works. The other thing that we need to know when we're looking at this is the special right triangles. It'll make the problems go faster. If I ask you to solve a 30, 60, 90 using a special right triangle, then you need to use that and not sine, cosine, or tangent. So the two special right triangles that we have are the 45, 45, 90. So if you know two sides are congruent, you know that both these angles here have to be 45. If you know that both the angles are 45, then the sides have to be congruent. And the pattern for that is A, and A rad 2. That is the only one that you can use the Pythagorean theorem on, given that you know two sides, or even one side. The other special right triangle is the 30, 60, 90. The side, the leg that is closest to the 60 would be A. The hypotenuse would be 2A. And the longest side would be A rad 3. Looking at this next problem right here, I notice that both of the legs are congruent to each other. So it is a 45, 45, 90. So it saves me a lot of work because I know this would be 6 rad 2 because this would be A, and A rad 2. The next problem, since this is 45, 45, I know that this is congruent to this, which makes this equal to A rad 2, A, and A. Well, 15 rad 2 equals A rad 2. If I divide both sides by rad 2, I have that 15 equals A. So this is 15, and this is 15. Knowing again the 45, 45, 90 triangles makes this go really fast and saves you time using the Pythagorean theorem. The next one says the length of the sides of a square is 10 meters. So you know, since it's a square, that every side equals the same. The diagonal cuts across the center. Since the sides are the same, again, we will have a 45, 45, 90 triangle. So this would be A, and A rad 2. So our answer would be 10 rad 2. The next two type of problems would be ones that I would say that you have to use a special right triangle on. I know you have the knowledge to be able to use trig on it now, but I will ask you on the test to use a special right triangle to solve it. So we have a 60, 30, 90. This side would be A, the hypotenuse would be 2A, and the longest side would be A rad 3. Since A is 5, 2A would be 2 times 5, which makes our missing side 10. And on this one, we have a 30, 60, 90. This would be A. This is a hypotenuse, so it would be 2A. The longest side is A rad 3. Well, if 2A equals 50, A equals 25, which makes this side here A, which is 25 rad 3. Now for the next problem, we are given this angle, which is 67 degrees, and one side. So we need to use either sine, cosine, or tangent to solve this problem. Looking at the problem, the first thing I'm going to mark is that this is a hypotenuse. This is the opposite, and this is the adjacent. I want to find the opposite, and I'm given the hypotenuse. The one function that has the opposite and the hypotenuse in it is sine. So I have sine 67 equals x over 20. 20 is in the denominator, and I want to solve that function. So I'm going to multiply now both sides by 20 so I can isolate x by itself. So 20 sine 67 equals x. Putting that into the calculator, I have 18.4. Going on to the next problem. Problem number 10. I want to find the measure of the angle of elevation of the sun when a pole 25 feet tall casts a shadow 52 feet long. So if this is my pole right here, and the sun is up here, the shadow it's going to cast is down this way onto the ground. So here's my pole, which is 25 feet tall. The shadow is 42 feet long. And I want to find this angle of elevation right here. I'll call it x. To find an angle, we have to use the inverse trig functions. Looking at this and labeling it again, this is a hypotenuse. This side is opposite the angle, so this is opposite, and this is adjacent. So I'm looking at opposite and adjacent. The function that has opposite and adjacent in it is tangent. So tangent x equals the opposite over the adjacent. I need to use the inverse on that number to be able to find the angle. To do that, you hit the second key, then the tangent key, 25 divided by 42, close parentheses. And I get 30.762, which would round to 30.8. Next problem is asking you which is the angle of depression. The angle of depression is the one that is looking down. To name that angle, O would have to be the vertex, AOT, or you could also name it TOA. The one that's on the multiple choice is AOT. For the next problem, problem number 12, if the two sides are congruent, we know we have a 45, 45, 90 triangle. So the sides would be A, and A rad 2. So if we know that A rad 2 equals 22, to solve for A, I would divide both sides by rad 2. I have A equals 22 divided by rad 2. I need to rationalize. So I have 22 rad 2. Rad 2 times rad 2 is 2. The other way to look at it is rad 2 times rad 2 is rad 4, which is 2. Simplifying this, I have 11 rad 2. So my final answer to this would be 11 rad 2. In a parallelogram, ABCD, AD, so the length right here of AD is 4. We know that this is 90 degrees. I want to find AF, which is this one right here. If the measure of angle D, so the measure of angle D right here is 60 degrees, this one has to be 30 degrees. So again, we have a 30, 60, 90. That makes this one A. And this side, which is our hypotenuse, is 2A. And this side would be A rad 3. So 2A equals 4. Divide both sides by 2. I have A equals 2. So X equals A rad 3, which gives me the final answer of 2 rad 3. On the next problem, we have a couple 30, 60, 90 triangles. So if I look at the first triangle right here, and we'll redraw it. Here's my right angle, here's my 60, here's my 30. This is 4 rad 3. Labeling the sides, this would be A. The hypotenuse would be 2A. And this longest side here would be A rad 3. Solving this for A, I have 2A equals 4 rad 3. Divide both sides by 2, and I have A equals 2 rad 3. I need to know this side right here, which is this side, which is my X. So X equals A rad 3, but we just found out that A was equal to 2 rad 3. So X equals 2 rad 3, rad 3, which is 2 times rad 3 is 3. So that is 6. So we know that X is 6. Redrawing this triangle here, let's do a different color. This is 30. This is 60. Here's my right triangle. This is A, 2A, and A rad 3. This is also Y. We just found out that this side here was 6. So that makes Y equals 2A. A was 6, so Y equals 2 times 6, which gives us that Y equals 12. So our answers here was that X equals 6 and y equals 12. On problem number 15, we want to find x to the nearest tenth. Again, labeling our sides, we have that this side here is the hypotenuse. Here's our angle. So this would be the side that's opposite the angle, which leaves this as the adjacent. We have the adjacent, we want to find the hypotenuse. So the function that has both the adjacent and the hypotenuse in it is cosine. So cosine 18 equals the adjacent, which is 9.2 over x. Algebraically, we're going to need to multiply both sides by the denominator, and the denominator here is x. So now we have x times cosine 18 equals 9.2. To get x by itself, I'm going to have to divide both sides by cosine 18. So I have x equals 9.2 divided by cosine 18, and that will give me 9.67. And it said to round to the nearest tenth, so my answer would be 9.7. In problem number 16, we've had this type of problem a few different times where you're given a triangle that's not a right triangle. They tell you it's an A-frame house, which makes it an isosceles triangle. So if I draw the altitude from that top angle down, it will divide the angle equally, the triangle, excuse me, equally in half, cutting this bottom in half. So I now have a right triangle where this is 15, this is 40, and I want to find that angle. Labeling the triangle again, this is the hypotenuse. This side is the opposite from the angle, and this is adjacent. So I have the opposite and the adjacent, and I want to find an angle. So I'm going to use the inverse function. I have opposite and adjacent, so it'd be the inverse function of tangent. To set it up, I know that tangent x equals the opposite over the adjacent. Using the inverse function, I have x equals tangent inverse of 40 divided by 15. To put that into your calculator, you would use second tangent, and then 40 divided by 15, close parentheses. The answer would be 69.44. And it's said to round to the nearest degree. So I would have 69 degrees. For those of you who keep asking if I'm going to require that you draw a picture for one of your problems, yes, it won't be a difficult one. Just like previous in this practice test, you just have to read and then draw. So I have a tree. So here's my tree. It casts a 12-foot shadow. So my 30-foot tree casts a 12-foot shadow. There's our right angle. Here's the hypotenuse. Find the measure of elevation of the sun to the nearest degree. So that's the angle of elevation, and I want to find x. So again, labeling the triangle, this is the hypotenuse. This would be opposite, and this is adjacent. So I have tangent, so tangent x equals opposite over adjacent. I want to find the angle, so I'm using the inverse function. Putting this into your calculator, you would do second tangent, 30 divided by 12, close parentheses. You want to round to the nearest degree, and our answer would be x equals 68 degrees. Continuing on, number 18. A boat is 1,000 meters from a cliff. So there's our 1,000 meters right there. Here's our right angle. If the angle of depression from the top of the cliff, so the angle of depression would be right here, if that is 15 degrees, that also tells us that the angle of elevation right here is 15 degrees. How tall is the cliff? So what I want to find is the x right here. Labeling this, I have the hypotenuse. This is opposite, and this is adjacent. So I have the adjacent. I want to find the opposite. That gives me that I'll be using tangent. So tangent 15 equals the opposite over the adjacent. Now this time it's the 1,000 that's in the denominator. So to get x by itself, I'm going to multiply both sides by 1,000, which will cancel that out. So I have x equals 1,000 times tangent 15. Putting that in the calculator and rounding to the nearest tenth, I have 267.9 meters. Problem number 19. A plane flying at an altitude of 10,000 feet begins descending when the end of the runway is about 50,000 feet from a point on the ground directly below the plane. So let's this be our plane. Here's a point directly below it. We know it is 10,000 feet in the air. We know this point is the end of the runway, which is 50,000. There's our right triangle. Whoops. Find the measure of the angle of descent. So this is the angle of depression right here. I'm going to call it x, but it's also the same as the angle of elevation, so I'll call that x there. Labeling my triangle, I have hypotenuse. This is the opposite, and this is the adjacent. I know the opposite, and I know the adjacent, so I'll be using tangent. So tangent x equals the opposite over the adjacent. So x equals tangent inverse because I want to find the angle of opposite over adjacent. Plugging that into the calculator, and I do admit you can reduce that 10,000 over 50,000 to 1/5 if that makes it easier for you. I do second tangent and I will have 11.3, and it says rounded to the nearest degree, so x equals 11, sorry about that, x equals 11 degrees. Last problem, the measures of the sides of a triangle are 56, 90, and 106. Use the Pythagorean theorem to classify the triangle as acute, obtuse, or right. So remember, it is a right triangle if a squared plus b squared equals c squared. If a squared plus b squared is greater than c squared, then we have obtuse. I spelled that totally wrong because that's an S. If a squared plus b squared is less than c squared, then we have acute. Excuse me, I got that backwards. If a squared plus b squared is greater than c squared, then this is acute, and this is obtuse, and I apologize for that. So let's look at this. If I look at 56 squared plus 90 squared, how does that compare to 106 squared? 56 squared plus 90 squared is 11,236. 106 squared is 11,236. So that equals each other. So it is a right triangle. You must show this work, and then you must give your answer. And that concludes the practice test.